La 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 la. La 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 la. La 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 la. La 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 la.
So here in this video, we are solving a problem based on potentiometer. It is given like this. In a potentiometer experiment, balancing length with a cell is 560 centimeter. Let's try to visualize what's the meaning of that quickly in a rough diagram. This is the wire of a potentiometer. This is the primary circuit. Of course, there's a key. I have not drawn it. That's okay, you can draw. This is the primary circuit. Now in the secondary circuit, he is saying he has connected a cell of EMF E1. It's then connected to high resistance and galvanometer. And when the jockey is kept at a distance of 560 centimeters, balancing length is formed. That's what he is saying. So you can say the balancing length through cell, because of the cell L1 is 560 centimeter. Now when an external resistance of 10 ohms is connected in parallel to the cell, now what is happening to this cell is connecting an external resistance R in parallel to that. Now the current passes through this external resistance. I won't get an EMF of total E, but I will get a part of a EMF through the external resistance. So what is that formula, right? So we can say, what's next we can say is, when external resistance of 10 ohms is connected parallel, balancing length is, he said, changed by 50 centimeters. See how it changes. L2 is always less than that of L1. Why? The potential drop across the resistance is always less than the EMF of secondary cell. Because it's a discharging cell, this will have some internal resistance. This E also will have some internal resistance. Because of that internal resistance, potential drop across the external resistance becomes less than the EMF of a cell. As V is less than E, balancing length shall be less than that of L1. So when he says, as length changes by 60 centimeter, it means to say length decreased by 60 centimeter when compared with the L1. So L2 will be 560 minus 60. It will be only 500. Then what's the internal resistance of the cell is the question. We know the formula. We have derived it earlier, right? Internal resistance is equal to, we have a formula, L1 minus L2 by L2 of external resistance connected in the secondary circuit. We have derived this in the other video. Please look into the playlist for the respective internal resistance derivation. So 560 minus 500 by 500 into external resistance is 10. That is 60 by 500 into 10. That is 600 by 500. That is 6 by 5. That is 1.2 ohms. So the internal resistance of this cell, we are talking about this cell, this R, is 1.2 ohms. This is how we can calculate the internal resistance using the concept of potentiometer. Thank you for watching.